Hi, this video is going to be doing some work with data points, parabolas, and doing some work to finding the dilation or stretch value is what we'll end up being focused on. A calculator will definitely be helpful for you in these notes, as our A values are going to be a little bit nasty. So here we go. You're going to be given a couple story problems that are very similar to this one. This one says, when golf great Allie McDonald hit a golf ball, it traveled a horizontal distance of 300 yards and reached a height of 26 yards at its highest point. Sketch a graph of the path of the golf ball and find the equation of the parabola that models it. So there's a big clue here for you that we're dealing with parabolas, or the path of the golf ball is going to take the shape of a parabola. Now I recognize in real life it's not always like that, because you have factors of like a wind gust coming through, or going into the woods with a tree, things like that. But if we just think of a classic parabola shape of a golf ball, I think it's going to be an upside down parabola. It starts on the ground, it ends on the ground, and at some point it hits its highest mark. And for the purpose of this problem, we're going to say it's fairly symmetrical as a parabola, where this is the horizontal distance and then this is the vertical distance, or the height. So let's think about that. If it travels a horizontal distance of 300 yards, this data point right here will be 300, 0, because it's gone 300 feet away and it's not in the air anymore. Now the vertex, the highest point, it says it's at a height of 26 yards, so that would be the y value. And now in theory, in math, parabolas are symmetrical, so the x value of the vertex would be half of 300. So I would say the vertex that for this parabola is 150, 26. All right, now we have some work to do to write the equation, find the equation. We are getting pretty comfortable with the equation of a parabola. Y equals a, then in parentheses you have the x minus h, where you have the horizontal shift, squared plus k, that gives you the vertical shift. Hopefully by now you recognize that the vertex is the h and the k, so we can fill in a lot of this. Just like that, we can fill in quite a bit there to get a sense of what this equation is. And we're almost done, in the sense that the only thing we still have to figure out is what this a value is right here. So how could I use this formula to solve for a? Well, I think if I had an x value and a y value that I could plug in, the only variable that I have left is an a, so I could solve for it. And sure enough, I mean, I've got the origin at 0, 0, but I think I'm going to choose a little more of an interesting point and do 300, 0. So I'm going to remember that x is 300, y is 0. So the y gets substituted in for a 0. The x gets a 300. And my goal is to solve for a. So to get that a alone, I'm going to start by subtracting 26 from both sides. So I have a negative 26 equals a. And then I could do some cleaning up here. 300 minus 150 is 150. And then 150 squared is 22,500a. And then I have that equals a negative 26. So this is going to be, when I solve for a, this is going to be a really quite small number. Let me get, if I can, the calculator going. So I've got just 26, negative 26, divided by 22,500. And I get a negative 0.0011, and then like a 5 repeating. Negative, nope, where am I? Sorry. It was a negative 0, 0, 1, then there are a bunch of 5. So we'll like 5, 5, 5, 5, 6, we'll just leave it there. It makes sense to me that our A value is negative. Can you think why does it make sense to you that the A value would be negative? Hopefully, your room right now, you're saying, oh, Miss Milton, because it's an upside down parabola. It's been reflected vertically, so it makes sense that that A value is negative. So we're going to take that answer and really plug it in right back here, because to have the formula done correctly, I need the 150 and I need the 26. So my final answer is going to be a y equals negative 0.0015 x minus 150 squared plus 26. I like that that A value is negative because that is the part in the formula that tells you there's a vertical reflection. So that would be equation that models the path of the golf ball that was hit. Let's try one more. This one, there's not a story problem involved. There's just a list of a bunch of data. It says this data is from one bounce of a basketball. Find an equation that fits the data over this domain. So if I kind of sketch this out just a little bit, if I think of one bounce of a ball, it looks like it makes sense. They've marked the time between 0.5 seconds and 1 second. So it's a really, really short period of time, but we could go like from 0 to 1 second to 2 seconds. And then if you look at the height, it's at a 0.05, and now it's going up, 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 the ball's going higher, 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 and it looks like right here it goes from 0.59 to 0.6 to 0.59 again, and then it starts going back down. So the course of this ball over time is kind of just like that is what it looks like to me. We've got this upside down parabola. And I want to tell you that in this list, the vertex is given to you. So the highest point of that parabola is given to us. So I'm looking at where is the height the highest, and it was right here at that 0.6. But the question is that the vertex? And I would argue it is, because this is 0.04 seconds away, and this is 0.04 seconds away, and notice how the height was the same. We're at 0.59, and then 0.04 seconds later it went to 0.6, and then 0.04 seconds later it went to 0.59 again. So there's that symmetry we're looking for. So we definitely have our vertex of 0.86 and 0.60. Okay? So let's think about this. To find an equation over this domain, well, the parent function is going to be a parabola, but this is definitely going to have a different, the vertex is not at the origin, it has a vertical shift, nope, has a vertical reflection, and it's going to have a different stretch. It's not going to be like the parent graph. So we're going to have to use this formula to help us figure out everything about this graph, about how it transformed. I'm going to start by plugging in what we decided the vertex was. And so now we're back to very quickly where we were in the last problem, where all we have to do is solve for A. So my challenge is can I find a different ordered pair on my graph to plug in? And the truth is, yeah, I have all of these ordered pairs. I could choose any one of these to plug in to solve for A. But I think there's some better choices than others, because data is messy in real life. And when you're not dealing with like theoretical math, the data is messy. And what happens real close to the vertex might not give you a great representation of what's really happening with this parabola. So I would encourage you to pick stuff far away from the vertex. It'll give us a better idea of the shape of this parabola. So for this example, I'm going to choose this one. I'm going to use the point 1.18 and 0.05 to help me find the dilation, to find the A value. So instead of the Y, I'm going to put in 0.05. Now to be clear, you could choose any of these. Your A value might be a little bit different, but I'm going to encourage you to pick something at one of the extremes. All right, then the x was 1.18. And now here's where a calculator might help us clean up a little bit. We're solving for a. The first thing I'm going to do is subtract the 0.6 from both sides. So I am at a negative 0.55, and then in my parentheses I've got a 0.32. And then with the help of a calculator, the 0.32 squared is 0.1024. I divide, and I'm going to pull up my calculator to make sure the calculations I did are correct. So when I look here, I'm just going to make sure the 0.32 squared is what I thought it was. Yep, 0.1024, and now I'm going to do a negative 0.55 divided by that 0.1024, and I get an A value of negative 5.37. Let's just start that again. That just wasn't working. A value of negative 5.37. I feel pretty good about the A value being negative because again, we have a parabola that's upside down that's been vertically reflected. So my final answer here, I was very close to having it all at this step, but now I can do it correctly filling in the A. So y equals a negative 5.37 x minus 0.86 squared plus 0.6. It makes sense to me that the A value is negative right there. That negative belongs there because that's where we show the vertical reflection. Yikes. How did I do that to the 5? Who knows? But that's just a little work with your calculator and working with parabolas and trying to find an equation that fits those points well. Hope you enjoyed the video. That's it for today.